everyone. Good morning, good afternoon, good evening, whatever applies to you, and welcome to ChefConf 21. I am Benny, the manager here at manager of DevRel and community here at Chef. I am joined by Lance Albertson. He is the director of the open source lab at Oregon State University. This is what I get for not writing things down before I have to read them. He's also an awesome chef winner and a huge part of the Sync chef community, because honestly, it's all one. A couple of quick housekeeping things. If you have questions, you can either hold them to the end or you can submit them through the Q&A here in Zoom. And keep yourself muted and off video until the end of the presentation. With that, take it away, Lance.
All right, thank you for having me. Welcome, everybody. Yeah, this is the Sync project update, the community rebuild of various chef projects. As Benny said, I'm Lance Albertson. I'm the director of the Oregon State University Open Source Lab here in Oregon. So let's go ahead and get started. So what is the Sync project? Well, it's a community rebuild, binary rebuild, I should say, and rebrand of various chef projects. Most notably, we make a rebuild of the client and the server, InSpec, and workstation currently. I'll go into more detail later about that, but that's currently what we're trying to target for. Some primary differences between the chef products and what we release. All the binaries are released under the Apache 2 license, unlike the Chef EULA. It complies with the Chef software trademark policy, which we do our best to do that. The binary names and path names are changed slightly so that there's no confusion that you're using Sync versus Chef. We've also disabled the license acceptance code because we don't need it because we're using the Apache license. And we've also included wrappers in various Chef binaries so the folks can still use their old, they've used it for so many years, but it'll let them know like, hey, we're actually redirecting this over to Sync. And the main thing is that we are not a fork. We are a rebuild. So you can kind of think of us as CentOS, at least how it used to be, rebuilds RHEL. So that's what we strive to do. So let's go back a little bit of history. So this all started back in April of 2019 when Chef changed the license on Chef. And it was quite the uproar in the community. And so a variety of folks were like, well, we still want to use it and we could rebuild it. We just have to go through the effort of doing it. And so Artem, Artem and Tensify, I think, was one of the first couple, and Mark, that started working on it. So Artem worked mostly on what was called at the time Sync Outspec. The Outspec was a little too close to the InSpec trademark, so we just changed it to Auditor. That's our InSpec rebuild. Tensify worked quite a bit on the GitLab pipeline works and some initial hosting. Mark, he started on the Sync client and eventually workstation. And then later on, Josh Gotland, Gitlin worked on Sync server rebranding work, and he's still working on it today because we have a lot of work to do, and I'll talk more about that later. I got involved a bit more after ChefConf that year because I was so busy with other stuff at work, and I got involved mostly on the infrastructure side and eventually the build and release pipeline. So the project naming, we initially were called the CC build for Community Chef Rebuild, but it was just too close to like a compiler name, and so we kind of had a voting thing with the project, and eventually we settled on Sync, which is a recursive acronym. Sync is not Chef, so I always wanted to have a project that had something like that, and now we have one. And also, I just wanted to also mention Matt Ray has been involved with the Sync project indirectly. He's been using our source code to build ARM32 builds of Sync, which really helped that community that needs it as well. So just wanted to mention that was really helpful for them. So what's the differences between Chef and Sync? As I mentioned before, the binary name. So most of the binary names, if they have some sort of Chef name, they've changed to Sync. In the case of InSpec, it is Sync-Auditor. We also include wrappers for what was the Chef binaries, but they output redirecting to whatever the Sync name is. So I'm sure users know that when they are using it, they know exactly. If we just put a symlink in, they wouldn't really know unless they looked at the screen and they see it saying that, and that's important. Some other things that we've changed is that in the installation artifacts, the installation and uninstall outputs well, say sync, we check for that. And then if you're doing manual installations with the Windows or the Mac OS packages, you'll see images when you do it that way. And so we try to replace as much as that with sync branding as much as we can, so we can fix that. Some other things that we've changed is directory paths. Everything is in their own new directory path. We don't use the Chef paths. It makes upgrades a lot easier. It can be confusing for some folks. There's some workarounds that I'll mention later on migrations that can be helpful, but this also ensures that we don't conflict with anybody using Chef. In theory, I suppose you could run Chef and sync at the same time, but I don't know why you would want to, but that's kind of the nice thing about it. And other than that, installation point of view, we have a different OmniTruck endpoint, which I'll talk about more later. Currently, we have no Yum app or app repositories. That's something we want to do. And then just doing Test Kitchen is a little bit different. And I'll talk a little bit more about that later. So that's kind of the major differences between Chef and Sync. So the biggest effort in the beginning was rebranding everything. And it was needed to comply with the trademark policy. We needed to make sure that users easily knew that they were using Sync and not Chef. And we also wanted to make sure we only changed what we needed to make it basically as close to the binary compatible to what Chef has. So over a lot of work, we worked through a lot of upstream changes to make our lives better. So in Ruby, we initially started out having a distribution Ruby file that was full of constants. And so in the Chef 15 era, that's where all those constants were. But in Chef 16 and beyond, we moved it into its own gem. Well, there's other stuff in Chef Utils, but that way other projects can just include Chef Utils without having to include all the dependencies that Chef has. And so it's a little bit more portable, because right now we're still working on it. Each gem that we have a distribution Ruby file in, we want to have it. We want to be able to say, okay, include this gem, and then that's it. So we have this distribution constants file, and I'll show an example here in a second. For the Go language, we use the Go generate feature with a JSON file. I'm not as familiar with that. I know enough that I can write a JSON file and run Go generate, and it does it. And it will replace a lot of the text that we have in anything that uses Go. There's a few places that use Go. And so the main thing is we want to be able to simplify the rebranding into a single location instead of trying to change every single file, because over time, those lines change. We have conflicts and everything, and it will just cause errors down the road and problems. So that's something we wanted to be sure of. So most of the support was driven by the Sync project members, putting pull requests into the repositories. We worked really closely with upstream to ensure we didn't break anything. I know we did break Bootstrap at one point, so we pulled that back. But hopefully now we can actually get that in place if it's not already. And the nice thing about this is once it gets in upstream just maintains the code. And any new code that gets in hopefully gets that applied. I try to keep track of the repository to make sure any new pull requests that come in, I can say, okay, I need to add this in now. I kind of keep to comply with the trademarks. It's really easy with how we have things set up in Ruby to do this rebranding, but all the other languages that are used in the Chef ecosystem can be a little more problematic, especially if community members such as me aren't as familiar with it. Thankfully, we have other community members that can do that. So that's part of the rebranding effort. So here's a little excerpt from Chef Utils. It's a very simple file that has some constants in it. So you can see we have the product set and the short set, and these are used throughout the code base. This is anywhere where the user would see it. We don't worry about all the innards of the code. It's only outward facing things. So if a user sees it while they're running Chef, that's something that we need to make sure that they change. And here's some examples of them in action. So you can see here when you actually fork. Oh, is there a question? Okay, I heard another. So here we see when the Chef forks, you can see here it uses the product constant here. And then actually inside the Chef client cron recipe, you can see it actually sets the default property value based on those settings as well. So it's great. And I'll show you an example of why that's really important down the road. So from a rebranding status point of view, I really consider client and auditor complete, although it's ongoing because new code goes in and we have to make sure it's there. Sync workstation is almost complete. I'll talk more about that in the next slide. I'd say we're about halfway there with Sync server. It's probably technically more, but there's a whole bunch of extra work that we're going to have to go through, and I'll talk about that in a little bit. For Sync dashboard or automate rebuild, very early development. I know Tensify took a look at it one point, But we've been so busy focusing on server and workstation, we haven't had time to take a look at it. And we haven't even looked at Habitat or Packager yet, because Biome is out there and it seems to be filling that need so far. So from a Chef workstation point of view, a pathway to what we consider stable, we have 4 things that we really need to work on. We need to work on Chef Apply, Jim. There's some manually patched things that we have included now that suffice, but we really need to get that upstream and get it rebased and updated properly. The PR hasn't been touched in a while, and so we need to do that. The Chef main wrapper, that is the Go binary wrapper for the Chef binary that we actually renamed to Sync. We currently, some of it is already has some rebranding parts in it for the Go generate, but a lot of like the help values weren't, at least at the time. And so we've been manually just changing that so that we can at least comply with the trademark, but we need to properly get that justified in the upstream distribute repository. And then a more new binary came in, the Chef Automate Collect. We just got the upstream patch merged. I think that was a Golang one as well. And I haven't verified, but I think we just need to make sure our build environment use the generate command properly and gets that going. And then the final thing is just getting the word mark sign off from the community. And we need to go through and make sure that any output that we see, people will know that, hey, this is Sync and it's not Chef. So let's talk about Sync server, getting it towards stable. So right now we're manually changing a lot of the references in the word marks instead of using distribution constants. And this is because server has been using, up until recently, it was using Chef Info Client 12, and then more recently it updated to 15 and 16 and 17 in the latest releases. We weren't able to use the constants like we wanted to, and there was a lot of work upstream, and really happy that they finally got through all of that, and thank you so much for doing that. And so in version 14.3, that was the first one that included 16, which has the Chef Utils gem, which is what we needed. And the more recent version has 17. So that is really where we're at right now. And I know Josh Gitlin, he's been working quite a bit, or he's trying to find time to do that. That's the next step, is we need to make some upstream pull requests that cover a lot of things. And I've kind of covered some of the areas here on the right. This is on our bug tracker that we had. And a lot of it is either some gems that have some references, or you can see down below, those are the private cookbooks that the server uses to actually bootstrap itself and manage itself. So there's a lot of various things that we need to kind of take a look at. From Nginx, it's some just, I think it's probably just some pages that you see and so forth. I don't think we have Chef Manage on here, and I know that's going away eventually. So I don't know what we're doing with that, but a lot of work. But the good thing is that the server package that we have out now, as far as I know from people, it works. It may not be completely trademark free, but it works. So that's where we're at with server. So if you're looking into migrating from Chef to Sync, here's kind of a pathway that we did at the Open Source Lab. One thing that we did to make things easier on us is that before we did all the upgrades, we put in our recipe a symlink between the old paths to the new paths for the configuration files and the cached content. And we did this because we didn't want to trigger some of the resources that assumed that files, if they didn't exist in var sync or var chef cache, would trigger again and cause potential issues. It shouldn't, but you never know. So we did that on all the systems just to make sure we didn't have any problems. After the upgrade, you don't need to have that symlink at all. And after that, we just uninstalled the Chef package. We may need to manually clean up anything that's in opt chef, which is where the package files are. And then we install sync in any method you want. And then we just run sync client. And any of the gems that you used with Chef Gem will have to be reinstalled again because you're in a new environment. But other than that, nothing else should change other than anything that has templating that maybe refers to the constants that we have, like in the Chef client cron, that might change. So just kind of be aware that, you know, there might be some template changes. And of course, this migration process can be really automated depending on your environment. So I think I remember seeing some folks on Slack saying, yeah, we've automated it and this is what we did. So for us, you know, we don't have thousands of machines. We could kind of do this manually one by one. We had it set up where we just went to one machine. We did this process, made sure it worked, and went to the next machine. And all of our code was kind of like, I can work either on Chef 14 or Sync 15. And we just made it work. It was really, really beautiful. So here's an example of one thing that we've seen come up is the Chef Client cron or any of the Chef Client resources related to that. So if you're using Sync Client 16 or above, there's a native resource. And as you saw on the previous slide, it uses the distro constants. And I verified this morning because I hadn't actually tested this myself. You can just use the default client resource and it just works. It's great. That's how it's supposed to do. If you're using 15 or below and you're using the cookbook, you'll need to set some of the names. Actually, I guess you don't need to have that, but you need to set some of the paths directly because the resource is assuming chef, obviously. So that's great. One great way of being able to do that. Another useful resource that people use, this is in a Chef Client cookbook, I believe. This allows you to manage upgrading your client. And thankfully, you don't need to change anything in the code base to get this to work. You just need to change the product name to point to our OmniTruck name. And then you need to change the Ruby Gems URL to point to our package cloud repository, which is where we have our patched mixlib install gem, which points to all of our endpoints. So it knows to install sync from our side, not from Chef. So that's all that really needs to happen to get that to work. And it's great. We've been using this at the lab for years and haven't had any issue. Now to use with Test Kitchen, really, I've never really tried doing it with Chef Workstation, but with Sync Workstation, this is what you need to do. So the main thing you need to change, at least if you're doing Vagrant based, just change the product name to Sync. Sync Workstation should already have the mixlib install gem installed that points to all of our endpoints. One interesting tidbit to note is that if you're trying to run this on Windows, or I should say, if you're running a Windows VM with your Test Kitchen environment, you do need to set the Chef Client path directly to what is used there. That's something I'd like to get fixed upstream at some point. That's because on Linux, we have the wrapper there and it's in the main path. And so it just assumes it can find it there. Here, it's in an entirely different path and we don't want to conflict with Chef. So we're kind of working around that. For Docker, we also work great. We publish our own Docker images using the same Docker file that Chef uses. We just changed a few things to point to our stuff. And so you just change the Chef image name to that, and then you change the binary path to where it needs to, it should just work. It's great. So let's talk about our development environment and our repository structure for how we have things have set up. So all of our code development is done on GitLab and is mirrored on GitHub. This was done because the initial Sync members and contributors were more familiar with GitLab at the time. And the nice benefit that happened at the same time is that allowed us to easily add our own custom CI runners. At the time, I don't think GitHub quite had that ability with GitHub Actions. I don't know if even GitHub Actions existed at that point. If it was very early. So it was very, very nice. We could run our own runners to build the software very easily. So this is where we currently stand with the org structure. At the very top, we have the Sync Dash project, and then we have two folders. We have the distribution and the mainstream or upstream folder. The distribution folder has all of the scripts for building Sync. And so we have things like client, server, workstation, and I think auditor in there as well. And so that's where all the scripts have the CI configuration, all of that. Under the upstream folder, that's where we keep our copies of our repositories that are basically copied from upstream. So we have a Chef one, which is the exact same code base that Chef has, but on the first couple of commits on top of it have our rebranding changes. You can see exactly what we have. And I'll talk a little bit more how that's structured later, but so all the upstream repositories that we use to have our own specific patches are under those upstream folders. All the builds happen as pipelines under the repositories in the distribution folder. And some of the upstream folders, like Chef, we have it going to this distribution one so that we can actually test things a little bit better if we need to have a slight little change or a fix to our patches as well. So let's also talk about how our upstream repositories are set up with branches, and we'll use Chef as an example of this. So we do things slightly differently. The main branch, or what you would consider main or master, is stable sync. So that is what we consider stable, and that's where everything is at. So this should be close to the tip of upstream as possible. And this should contain all of the sync specific changes that we need for rebranding, or any minor fixes that we need to do to make it work that haven't been quite included upstream yet. This is manually rebased with upstream master main branch when releases happen or whenever we need to do some code or if there's merge conflicts. And this branch is frequently force pushed because we want to keep our patches on the top of the upstream code so we know where it's at. As stable releases happen, we'll create version branch names. And this is based off of the release get tag. So an example of Chef, they have a V in front of the number. Workstation doesn't have the V. So we follow whatever the get tag is just to make it easier. And this makes it easier so that we can see at a set of time, these patches are applied this way. And we can go back, and if we need to make a fix for whatever reason, we can go back and change it. I thought about doing this with get tags itself, but I felt this was a little bit more flexible for us in the end. And it basically does the same thing. Another common branch layout you might see it on sync server is unstable sync. So we're still in the progress of getting things going. We're doing a lot of changes, and so it's probably going to change quite a bit. And it didn't make sense to have the stable branch be changing a lot. So we have unstable. And eventually that'll go away and it'll just be stable sync once we get everything sorted out. So that's kind of most of what we have for branches that you should see out there. In the distribution repositories, we have the GitLab YAML configuration, which has all the logic that we need for building, testing, releasing binaries. In some repositories, we have common logic split out into separate files, so it's a little bit easier to manage. That was fun learning how to do that with GitLab. And this is pretty much the common build stages that we have, and I'll go in a little bit more on each of those, but this is the most common set of, we patch the code, we package it, or build it, we test it, we do some cleanup, we deploy it to internal servers, and then we publish it out to the world. And then also the repositories have any scripts that we use for building, easing in the CI pipeline, or if you want to debug or do development, it makes it pretty easy to do that. Something I'd love to be able to do eventually there is kind of have a central package that we have included in there that is just shipped in our containers or wherever, instead of manually keeping each repository up to date. But it is what it is. So as far as runners go, we don't use any shared runners anymore. I've made a decision that the open source lab can offer runners. It's to our benefit because we use sync, so it's great. So we have a variety of x86 systems. We have a variety of VMs running on our OpenStack cluster that are running Docker for building Linux systems. We have a VirtualBox instance. It's actually a nested virtualization environment, so it's not as bad as you think. But we use that primarily for testing Chef servers because we can't test that inside of the Docker containers easily. We have another utility mirror server that's hidden from the world where we kind of pull in everything using the shell executor, and then we could push it out to the world. We have a Windows VM. It's that version because if you wanted something to work on a version old and newer, you build it on the oldest one and it supports everything after. It's annoying. So that's currently the version that Chef is supporting, and that's what we're trying to do ourselves. Then we have macOS VMs running as well, so we can build on each of the various platforms. For ARM, we have VMs for that. We also have a Mac Mini that's running the ARM 64 as well. We have VMs on PowerPC, and I also have access to S390X. It's not hosted at the lab. Right now I do it manually, but I'm hoping to get a shared runner set up because this is one that's going to be shared among other projects, not just sync. And currently working on getting that going. But for now, I've just been manually building it on those runners and adding it into the mirror and all that. But that's currently our all the systems that build and maintain sync right now. So before we go any farther, I need to talk about Omnibus, because Omnibus is all about how we build. And this is what Chef uses to build. It's a full stack installer. It's used for building client, auditor, workstation, server. I have a link there for the upstream repository. It basically creates a self-contained environment for all your dependencies. I think even GitLab uses it for a way of distributing GitLab open source, among other things. You don't really rely anything on the host other than the bare minimum, for example, glibc and GCC, that's about it. And it allows you to use various versions of Ruby and other newer things that are better than what you get on the distribution. And then it creates all the packages, it signs it if you have that support built in. And then it generates metadata that's used for Mixlib and Omnitruk and all of that. So the changes that we've made is under the Omnibus software repository that contains all the various software dependencies that you use. And under there, there's a Chef project, which is actually used to build Chef. And so we made a few little minor changes in there so that we can build Chef using our changes right there really easily. Other than that, each project has its own Omnibus configuration, and we've made some rebranding and disk changes in there as well. So that's where the post-installation scripts and so forth have been updated. And it works really, really well. As far as I can tell, Automate and Habitat do not use Omnibus for building. They primarily use Habitat to build. So our build environment, for Linux, we basically build everything in containers because it's easy to spin up and destroy. It's really easy. Mac and Windows are more interesting. We have dedicated VMs or bare metal machines. These are currently managed manually, which is annoying. We haven't built an Angry Sync client, which is basically a sync client that is in a separate path than it normally is, so it doesn't interfere when we're trying to build Chef or Sync on there. And it's also important that we have everything to be clean in the environment on every single build. And that's important. That's what gets to be a problem. And it also limits us to only doing one build at a time on that system. We can't have multiple builds running on it without spinning extra VMs or hardware for that. So currently what's installed on these systems is we use the Omnibus cookbook, which unfortunately is deprecated upstream. It installs most of the build environment to similar to what upstream does. I think they do things differently now, which is why that's deprecated. They probably build images slightly differently in a different way, which I can't see, which is fine. But we plan on basically taking this cookbook and managing it ourselves eventually, or renaming it or something, because it's really useful for how we build things and update it. Another important package is there's an Omnibus toolchain package that contains very basic software, so very basic Ruby and some very common toolchain libraries that we need to get things started, so we don't have to depend on what's installed in the system per se. So the only thing you need on the system is GCC and glibc basically, or whatever system libraries, and then the rest of it's contained in Omnibus toolchain. So we have a known environment and we know how to build it, which can create issues down the road. I know with the Windows build of it, there was a big change where they had some IMSys2 stuff included, and then they removed it. So then I had to manually add it to the system and figure that out, and then all fun. But that's essentially what's on there. You can see, if you look at the Docker images, the Docker file, you can see how this is done, and it's fairly easy. So sync gems. So we do have gems, but we put them on Package Cloud. These gems have all the disk changes that we have already packaged in it. Some of these are published automatically in the pipeline. Some of them I do manually as they have updates. We don't put them on Ruby gems because we don't rename the gems, except I think in one case. If we would rename all of the gems, then we would have to change all the dependencies and all the gem locks, and it would not be fun. So we just keep everything the same, except in a very few places. And we point it to that source, and it works really well. Most users shouldn't use that Package Cloud repository other than installing Mixlib and, for example, the Chef client updater. And that's about it. It also gives us flexibility to publish what we want when we want it, and so forth. These are only used during the installation phase using Omnibus. After that, it's not needed. And then as we build certain things, Chef client pulls from Sync auditor gems. So we have to update the gem file to point to our source for that. And then Sync workstation has a whole bunch of other gems that we have to pull in. And then we have to point to our side, our repository, and we have to make sure we have the exact same versions every time, which is fun. And a lot of these, like the Chef CLI, I'll manually see an update, I'll rebase, do the same process, and then I'll just manually publish it to the repository. I'll see the change in the log files, like, okay, they did this version, so we need to use this version. With Sync Server, we do the same thing, and we will need to. That's basically why we haven't built the last two releases, I realized, is that the good news is it has Chef utils. The bad news is we're not using it properly with our setup, so we got to fix that. So we're going to have to follow what we did in Workstation, but doing the same in Server to fix all of that. So OmniTruck is what's used as a simple web service to easily download and install the Omnibus artifacts and packages for Sync. And so we replicate that on the Sync side as well. So it utilizes Mixlib install quite a bit, which basically relies on the Artifactory endpoint. And I'll talk a little bit more in a little bit on that. We have a little script on the next slide I'll talk about that creates a static endpoint that mixlib install can talk to and easily understand. We have a couple of changes. We got some upstream changes with some distribution constants in there, and we've applied that in that repository. So that's how we have that there. We just have this running on a simple server. We're not doing it with a whole bunch of Kubernetes and all that, I think like what Chef does, but we have it running on a small little instance with systemd, and it works fine. As I mentioned before, mixlib installed is included in Workstation, and it's our endpoint for everything, and it works natively on Sync Workstation. So Sync mixlib API, this is a script I wrote way back in the beginning. And the main thing is I didn't want us to rely on some closed source platform such as Artifactory, even though it's an amazing product from what I understand. We didn't want to add that complexity to the system. And I was really familiar with a traditional mirroring platform, and we didn't need to have a dynamic API for this. So I figured out that we could generate all of the JSON APIs using a script by just combing through all of the Omnibus artifacts and creating everything. So it's just a simple script that basically goes through a directory. It knows what to look for. It finds the API file or the JSON files, and then it creates the known API that it needs. And we have this automatically running in the publish phase in the build pipeline. So we don't have to do anything other than having it in the build pipeline. And this really relies on having a very specific folder structure. So we mimic very much what Upstream does. You have the files, the channel, the product, the platform, and then the platform version. So it could be files, stable, sync, EL for enterprise Linux, and 8 for enterprise version Linux 8. And then under there, you would have the actual artifacts. During the pipeline build phase, we make sure we move all the artifacts into the correct locations with the directory structures so that we don't have to do anything else at the end. So it's really nice. So this is the directory structure that mixlib install expects on the system. So we have all of the various binaries here. You can see we did this in the very initial setting. And you can see there's a metadata JSON that has all the checksums, installed software, all that fun stuff that mixlib install needs to know, and extra stuff we don't really use, but it's there anyway. So now let's move on to the build process. I mentioned this earlier. So the first phase is patch. There's generally a patch.sh file, and it'll check out the upstream repository, either at the master branch or a specific tag that we ask when we do a build. It then adds the sync upstream repository as a new Git remote source, and then it does a rebase on that repository on that. So we try to make sure that everything is up to sync, at least to where we need it to be. And if all goes well, that rebase will not have any conflicts, and we'll have a new branded source that is now sync build. It'll build sync when we want to. So then that picks up all that source artifacts, and then we go to the package phase where we actually build sync using Omnibus. So we basically just run the Omnibus building script, and it just does everything. And if that passes, it'll spit out artifacts and the known paths that we want, and then we'll actually test the build using Sync Auditor. And so we have some very basic profile definitions. So we make sure that we don't see Chef where we don't expect. So in case something happens upstream that changed, we'll catch it during this phase and we can fix it. And we try to keep adding. That's our way of ensuring that we're complying with trademark. After every platform passes, we go to a deploy phase, which is basically it pulls in all the artifacts and then it pushes it to the hidden mirror into an incoming folder using rsync and SSH. And then the next phase on the actual hidden mirror, it'll run the API script, the sync mixlib API, and it'll generate all the API files on the new files. It'll copy all the files until where we need it, and it'll push the artifacts up to the mirror. And then separately on separate build pipelines, if we build Docker images, we'll do that there. And then if we patch any of the gems and push them to the package cloud repository, we'll do that in a separate step as well. And then at the very end, for any systems that's not Docker-based, we do some extra cleanup to make sure the next build that happens has a clean slate. We don't have any extra files laying around from a failed build or whatever. So that's kind of what the build process looks like, more or less. The update process is a manual one. We wanted to have this more automated, but there's so many moving parts that it really needs to have human eyes to do this properly. Often there's rebase conflicts depending on how we have things patched, and we always have to manually do it. Also, dependent gems change and need to be updated. Mostly in the case of Workstation, there's a lot of that. I'll look at the gem lock file and see if there's any changes. So I'll pull the latest Git commits from upstream. I'll do a Git remote update. I'll do a rebase of the master branch onto our stable, and then I'll resolve any conflicts that happen. And then I'll force push that back up. So now we're at the tip of everything. If it's a stable branch, I'll create a new branch that has that tag, as I mentioned earlier. And this is the part where, depending on the project, I may have to rewrite Git history just a little bit to get it correct. So in some cases, due to how Chef does their release process, the actual commit that updates the Docker file version and the changelog happens after the tag that gets tagged. And so I'll need to verify that I get that. And then sometimes another PR might get merged in the middle of the release happening, which can take a little bit longer. And so the history gets all messed up. So I'll usually take a look at starting at that tag release. And I know when we have our commits and I just remove the commits that aren't a part of that release. And so then it rewrites that and make sure that we get it correct. And that also happens if I pull up from upstream master and they've already gone a couple of releases ahead of what was released, and I can make sure that, okay, this is actually the release. And sometimes I'll actually look at the build artifact from Chef to make sure, okay, I'm at the correct checksum, one ahead, and I'm good. So once I get a branch that's set, I push that new tag branch up to a repository. I also check the gem lock files in the various places, especially in Workstation, and see, okay, there are any changes in the gems that we also patched that we need to update as well. And then I'll just go repeat that process through those gems and manually upload them. Once all is said and done, I'll get into the GitLab pipeline window for that particular product. I'll start a pipeline. I'll set the ref to that version tag, and I'll set the channel to stable, and I press go, and I hope that it builds. And if everything passes, it waits for me to press the release button. I don't want to have it automatically do that, just in case something happens. A lot of times I will take the build artifact from GitLab and I'll do a diff between the version manifest, or actually I'll do like a gem list on both of them and take a look and be like, okay, is this pretty much identical other than the things I expect? Because I want to make sure that I get it as close as possible. Unfortunately, sometimes the AWS gems there's a new release that happens and those aren't pinned strictly for good reason. And so we might ship out a slightly newer version of some AWS gem, but otherwise everything is exactly the same. One thing to note, from what I understand right now, InSpec does not have a gemfile.log file. So we have to make sure that when we build it fairly close to when the release happens. Otherwise, we might accidentally pull in something newer. So I have an issue open for that, but that's currently something we have to deal with on the InSpec build. So if you want to do development with Sync, at least on Linux, this is what you would do. You would clone the client repository, go in the directory, and then you would use our Omnibus Docker image that has all that software that we have. These are the same container images that we used to build it with. So we wanted to take the current directory, make that the working directory, and pull this in. We want to load all of the environment in there so that we're actually using everything from the Omnibus toolchain, and then we patch everything. And then if you want to have Git caching enabled, so if you want to be able to just test this one part where it's failing, it has Omnibus has a Git caching feature, and it's great. And after that, you run the build script, and that'll build an artifact. You get out of the container, you can start a new container, and we'll just use the stock CentOS one, and then we just yum install it, and we can test it and see what we do. That's basically what we do on our build process, and then we run auditor and check everything. So it's a pretty simple process. It's very similar to what we have on Windows or Mac OS. I need to make some PowerShell scripts to make it a little bit easier. I think I have it in some places, but not everything. We also can use some environment variables. I mentioned this earlier. So here, say for example, this was the version that the latest version I did when I did this presentation. I already made the upstream repository or the upstream tagged branch. So when I go to, if I want to test a local build of it, I can just do this, and then this will pull in the branch that I want. It assumes that ref exists upstream, and it'll patch it. If I have a test branch that I've pushed upstream that I want to test, I can also use a sync reference ref to do the same thing there for testing. And I can also do that in the pipelining if I wanted to. We have this enabled on the builders, but if you want to try building with FIPS mode enabled, you need to have that enabled there, but that obviously assumes that you have a platform which supports it. So let's talk about the release channels and how we use them. And we use them differently than how Upstream uses it. So what we consider stable means it complies with the trademark policy to the best of our knowledge. It should also only be the stable upstream releases. I'll watch them as they come through on Discourse and make sure that we get that going. Currently, client and auditor are the ones that are in this channel. Unstable may not completely comply with the trademark policy. So use at your own caution, probably okay, but just, something to be known about. We may still have some issues. It may change. We usually only push stable upstream releases there. And currently Workstation and Server are in that. There's a third channel that we don't currently use. It's called Current, but that's probably somewhere we can put some ad hoc builds that aren't tied to a specific version. So if we just want to build a quick one that's on the master branch, there we go. We got it. We can test it. Everybody can see it and go from there. So issues we've run into quite a bit. The biggest issues that we've run into is build issues. The build environment differences between what Upstream has set up and what we have set up always has unexpected errors. In fact, I'm running into one right now trying to build the client 16.14 version. For whatever reason, I can't build it on OpenSUSE 15 on ARM64. I get this weird error. And I have no idea. I don't know if it's a Docker problem or something else. So it's weird things like that. But I really run into this to the Windows environment because one, I'm not as experienced with building these types of projects on Windows. I guess I know more now than I did before, but also there's just a lot of moving parts. And for the longest time, we had to log in the version of the GCC we had. I recently updated that, but now I've been seeing problems with OpenSSL on Windows, not working quite right. So I think I might need to backport that. There's always these weird things. And also it just takes forever to build on Windows. Also, any kind of upstream library change that might happen. Even on the platform, we had some issues on Mac OS even, where we're running a little bit ahead of what Chef uses for their builds, and so we run into something, which is probably better for Chef because then we fix it or we at least report it and they know about it and they'll probably run into it eventually themselves. So that's good. Rebranding was a big thing, still is. Workstation includes the Chef Workstation app. I think it was originally a Node.js app, and now I think it's an Electron app. But at the time, it would not build on Windows for us. No matter what we did, it kept failing. And that's why we couldn't do a release of Windows for the longest time for Sync Workstation. And when I took a look at it, it really didn't provide a lot of value to Sync users. So we just removed it from the build. So that's a part of the modification we make in the Omnibus build for Workstation. We don't even include it. The other thing is just waiting for upstream work. So for Sync Server, we're waiting for them to get a newer client on there. And there's a lot of work that had to be done on their end to do that. That's what we're waiting on that, or any PRs that we have open that need to be reviewed. We also need to keep track of any new gems or projects that are applied to that project to make sure that any rebranding is applied and we catch those as they come in. I try to watch those PRs as they come in. So it's really important. So for the non-Ruby non-Omnibus builds, Automate and Habitat don't use Omnibus, so that's something completely new we have to look into. And the rebranding work on that is going to be completely different than what we've done with all these Ruby-based projects. And so we also have to take a look at the build pipeline and the tooling and what we need to change to make that happen. And also just volunteer time. I do this, I justify the time that I spend with Sync at the lab as something because it benefits us because we use it. But, I have my own priorities, whether it be, other things that happen in work or real life. For example, in the last 2 weeks, I had to deal with a Sequoia kernel vulnerability and rebooting systems, and it sucked up all my time. That's why our releases are a little behind. So, that's kind of what we've run into. So getting towards the end here, accomplishments in the past year. So we finally have some decent builds of Sync workstations and with Windows, Sync Server as well. We added new architectures and the latest platforms. I was able to get the OSL to purchase additional new Mac Minis, including the ARM-based one. And because the old Mac OS Mini or the Mac Mini that we used was from like 2010, it was slower than molasses. So it was so much faster now in those builds. I also updated the Windows build environment and improved that quite a bit, and some other adjustments in the GitLab pipeline. And of course, there's various bug fixes and things like that. Actually, one recent one I ran into was our Omnibus wasn't properly working for OpenSUSE users somewhat, and I fixed that problem, which was good. So let's go through a little bit of download statistics. I went through and our data, and this is the amount of gigabytes transferred per month of what's happening. So you can kind of see on our inception around 2019, kind of had a slow pickup, and you can definitely see a pickup here. And I didn't look in the logs to see those spikes, but I'm assuming that's either somebody doing a lot of testing, kitchen testing, it could be even us, or it could be somebody doing a migration all at once and seeing those spikes. But you can definitely see the trend line there. You can also see the number of download hits on our mirrors as well right now. You can see there's that large spike that happened at the end of 2020 with some users. So nice growth on everything. So future plans, I want to finally get apt and Yum repositories out there. I want to replicate what Upstream uses, but I also want to utilize hard linking on the mirrors so that we don't replicate a lot of disk space. I started working on this, but it's just having so many other things going, it's quite annoying. The other thing I want to do, and I know this is important for a lot of people, is signed binaries. A lot of the package formats have some signing ability in there. One thing I just don't see us doing is signing older releases, because it just would have to change all the checksums of everything, and it would just not work. So we'll make a big announcement when that happens, and you'll just know that from this release onward, it's signed, and you know it's signed. So we're working towards that. I'm hoping we'll finally have workstation and server in a stable channel. Hoping to add the HTTPS endpoint on our binary mirror. It's an OSL student working on it right now. Acme DNS is fun, I'll tell you that. Also looking into possibly getting a CDN in front of everything. That'll help a lot of non-US users. Right now it's hosted on the OSL mirrors, which are in here in Oregon, Chicago, and New York. So it's nice for people in the US, but not so great other ways. And eventually we'll probably look into dashboard, because we're getting a lot more people asking about the Automate rebuild. I don't really foresee us looking at the packager anytime soon. Biome really satisfies that. We actually include Biome in our workstation build instead of Habitat. So that's how that works. And I'm also hoping to finally formalize the project in some type of umbrella nonprofit organization like the Software Freedom Conservancy. That way we could take in monetary donations, and also we could sign contracts like we need for the CDN. And I don't have to sign it. I can't have the university do it. I want to kind of have it separated from everything. So special thanks. I want to thank Chef and Progress, amazing support and patience for all the community needs we've had, all the bugging we had to do on Chef server getting updated, and also for being very accepting of all of our pull requests, and that all support sync and actually help them as well. I think we actually discovered some bugs that fixed some stuff on the end. And a special thanks to Tim Smith, Lamont, Benny, and so many other current and past employees that have helped us along the way getting this going. Without them, we wouldn't have been able to do this. So this is amazing. And also the sync community, all of the main contributors, Artem, Tetsubai, Mark, and Josh, you're great. And all of our users that help give us feedback and let us know, hey, this is broken, and being patient with us as well. And our sponsors, the lab, OSU, GitLab for hosting our GitLab stuff, and Package Cloud for the GEMS repository. So with that, I'm at the end, and we are open for any questions.
That was awesome, Lance. I haven't seen any questions come in, but I do have one that I have. I know that so this has been an ongoing thing since the license change in 2019. God, 2020.
I had to actually look it up because I couldn't remember what year it was, because last year was a blur.
Yeah. So I know that there's been a lot going on. If somebody else wanted to build their own distribution, what do you think is going to be the thing that they hit the hardest? Like, what's going to be the thing that causes them to just like, you know what, I don't want to do this, never mind.
Well, if they're building on Windows, that's going to be really hard. I haven't done a really good job of documenting how all of this presentation really is the best documentation of it so far, so to speak.
Yep.
And that was one reason why I wanted to do it. And you would have to look at our GitLab CI pipeline to kind of see how that all works. Building it on Linux is pretty easy. So as long as you use the Docker containers and follow our steps, it's a breeze. Mac OS, it's not as bad. You have to make sure you have some other things installed, but it works. Windows, yeah, it's the whole thing. And I'd like to document it at some point. And I know Chef documents it somewhat, but it's also kind of your trade secret how you build it. So
Yeah.
it's kind of fun for me to figure out. I try not to poke you guys too much, but there's certain things that's like, I'm running into this and I have no idea why I'm running into this. Have you seen this?
Man, I love kinds of crazy stuff in there. Just to be super clear, I don't know either. I'd probably tell you, but
I know that I think there was a Debian packager at one point that has been using our sources for building sync and including it in the Debian archive, I think. At
Very
one point, I think Ubuntu was using the Chef stuff, or they used our binaries, or at least part of it, and they called it sync, but it was actually Chef. And we had to open an issue and get that resolved. I think it
yeah.
finally got resolved, but but yeah, I know for the client, we have like a source tarball that we put out there. I need to do the same with the other projects so that people can reproduce it a little bit easier. Because it should be reproducible for most folks, at least to a certain point, obviously.
Yeah. Cool. Are there any other questions from our small crowd of people? No, nothing. Awesome.
Awesome.
Well, go ahead.
I do have time. Do I have time to do my live demo or not?
I would say, how long is it?
Well, I guess I have 6 minutes to do it. We'll see. I was going to try and at least walk through the process of getting the next sync workstation release done. So
yeah, let's do that.
We'll do that really quick and see how that goes.
Awesome.
So let's see here. Let me make this full screen. Of course, it's not doing it, but whatever. Okay, so so I'm on our stable sync. I'm gonna do a remote update. I have no idea how this is gonna work right now. I have an upstream remote. What?
I just said live demos.
Live demos. So I have my upstream remote master, and we'll get to see what happens. And as noted, I always run into this because we have things set up. The Docker file is always a little bit different because I have set this to be unstable because we haven't set it stable yet. So this always conflicts. And I just rebase, continue, and yay, that was the only thing.
Yay.
And so now I'll force push that up. And I believe, yeah, it was this. So I will make a new branch. Yep, okay, and now I get to rewrite history. So as you can see here, this was the tag, but this is the actual commit that changes the change log. And I think that might change the, oh yeah, and it also changes the version of the Docker file. So if I go back, yeah, so let's see here. Take this, grab that. Okay, so I want that, but I don't want everything else in between here. And there's the start of the new one. So rewriting history, and voila, I have a new release. And I can double check and make sure I have the changes I need. It's from that patch. Okay, I'll push this up. This is where I might run out of time because workstation. So now I get to check the difference between the previous release and this release. And I get to see what's happened here. All the AWS gems. Oh yeah, of course, there's a knife update. Let's see, is there anything else in here? I don't do anything with train. So it looks like the only thing that changed was knife. So I get to update the Chef repo now. And I need to get back on stable. And it looks like I need to update my workstation here. So let me do an update and then I'll make sure I'm pointed to what's on GitLab.
I love this like speed run through. Let's see how quickly you can do it.
Oh wait, I'm doing this, not reset hard. Yeah, there we go. There's that one. Rebase, upstream, master. Yay. Force push that up. And of course, now Knife is shipped separately from Chef, so I have to do it special. And I forgot to check what that had. And it was, what release was it? There it is. It was 418. And these are released. Let's see here. Oh, I'm on, oops, wrong repository. There we go. Now I got it. Okay, so I need to check out this. Let's see here. Oh wait. And I've been doing it slightly different here. So I've just been doing knife dash and then the tag name because, oh wait, need to do this right. And now I need to find the tag. And I'm not going to worry about the change log because I know this actually contains the commit I need. Yeah, there's the knife bootstrap, so I got that right. So get that going, go into the knife folder. I built my gem. I got my package cloud. I don't have my command line interface set up, so I have to do it from the browser. And let's see here, git sync chef knife 418. There we go. If I don't do this, the omnibus build will fail because it can't find this gem. So that's there. I think that was it. So now I can go back over here. I can run pipeline. I set the ref to, what is it? It was, this is the tag. And since this is on unstable, I won't set the channel because by default it's unstable. And I run the pipeline. And I hope this all works. So we can quickly watch the patch go, the patch phase go, and then after that we can call it good because this will probably take 2 hours to finish because Windows. And hope that everything builds correctly.
My fingers are crossed.
Yeah, if it passes this part, then I can just go back and have a coffee or something and wait. And I just recently updated all of the omnibus containers because they've been horribly outdated. And there was a newer version and it fixed a few things, but it also created new problems that I had to work around.
Yeah.
Always the joys of if it's ain't broke, don't fix it, but then I kind of need a new thing.
Yep.
So,
Come on.
now we're just waiting for the image to download.
Josh in the chat said the first time I saw this process, I was thinking, wait, slow down. I'm trying to take notes here.
I've gone through this before with you.
I think that's what he's talking about.
No, the first time.
Yeah. So crazy. It was nuts watching you like speed run through that.
Yeah, I got it done in just under 10 minutes.
I know.
I'm thankful there weren't other
Let's go
updates.
through it fast. I'm comfortable.
What did you say, Josh?
I said the first time you demoed this, I was a little confused, but like I got it now, but you go through it very fast. You're
Yeah.
quite comfortable with the process.
Yeah, I've done it so many times. Yeah, it's especially with Chef Client, but when it was like I ran into that issue building 17 in the last week, it was so annoying. And when I finally fixed it, I was like, oh, that was such an easy fix. And now I can't even remember what it was. Oh, it was a bundler gem version issue, because during this process, at least in one of these things, we have to actually update the gem.lock file. And we used a different version of bundler, which you see here, we're finally doing, and it totally broke. That's where the whole, why am I pulling in Ruby Shadow on Windows when I know Windows doesn't use Shadow?
Yep.
That's a Unix thing. So yeah, here we're seeing it update the gem lock file for everything that gets installed here. And there it goes. It should go from there. Push that up and the rest of the pipeline should just work and go on. So
Nice.
yeah, it'll stop here. And then if I'll do a manual check of the artifacts for just one of the platforms, do a spot check, and then I'll just click deploy and the rest of it will just go.
Glorious.
So
Well, cool. If there are no other questions, then I think that about wraps it up. Thank you, Lance, for such an awesome presentation and speed running through the build. That was awesome.
yes, I was happy it worked.
Yeah, me too. Me too.
We'll see if it actually builds though. I'll let you know in a couple hours on Slack.
Right. Way to tempt the live demo gods and potentially win. Awesome. Well, thanks everybody who joined. We are sharing all of these presentations on the ChefConf website. So look for us at chef.io/chefconf.